Hello guys, welcome to the first pre-cal YouTube video. It is the 29th, I hope, and I hope you guys had a good weekend, and I hope that you guys are ready to go. And hopefully you have a calculator in front of you and this activity or these notes here. And let's get started. Let's get this going. LOL. All right, here we go. I guess read it, guys, first. So I'll give you a few seconds for that, and then we'll talk about some specifics. All right, hopefully that was enough time to read it. So pretty much you have a point, and this point is going counterclockwise. It's rotating, and it rotates 6 times per minute. I believe 6 times per minute. So that means, 6 revolutions per minute. So if it's doing 6 revolutions per minute, remember that in 1 minute there are 60 seconds. So that means it does 1 revolution every what? Every 10 seconds. So 1 revolution every 10 seconds. So I think that's enough. Let's see. The center of the water wheel is 6 feet above the surface, so that's going to be like your sinusoidal axis. They tell us that 13 is the highest point, so right there at that location, that is 13 feet above the surface of the water. And then, so if it's 13 feet and this is 6 feet, so then obviously it's 1 foot deep here. So I'm going to put -1 foot. So let's get going. So letter A, sketch the graph of D as a function of time t in seconds since you start the stopwatch. All right, so here we go. Make an X and Y grid and label your grid, guys. Don't just, don't just leave it without any units at all. So I'm going to say the X-axis here is in seconds. So I'm going to say T, and I'm going to put in parentheses S for seconds. And the Y-axis here is in feet. So I'm going to write feet. So the highest that this dude ever goes is 13 feet. So I would put, I'm going to say 13 is right here. And I'm just going to go. Oh, that noise that you hear is the fan of the laptop. It's using up a lot of horsepower. So I'll figure out how to mute it sometime in the future. All right. And let's see, the minimums, they go -1 feet down, guys. That's the slowest point. So I'm going to say this is -1 right here. Let's see, and then the sinusoidal axis, let's see, the center is going to be 6 feet above the surface of the water. So I'm going to say this is 6 right there. I think we're ready. All right, so the first point that you're going to plot, they tell us that at 2 seconds after you start your stopwatch, right here, 2 seconds after you start a stopwatch, point P on the rim of the wheels at its greatest height. So I'm going to say that 2 seconds is right here, guys. And I'm going to put a point. So I'm going to write 2 and I'm going to put a point. Now remember, you're doing 1 revolution every 10 seconds. So I'm going to go to 12. I'm going to say 12 is like right here. And I'm going to put another point. And I'm going to keep doing this. Make sure you space them evenly or they look symmetric, like they're all about equally spaced out. I'm going to keep doing this for a while. And let's do one more. I'm going to say that's the 42 there. Wow. All right, there we go. All right, so if it repeats every 10 seconds, in the middle between 2 and 12, you have a minimum, guys. So I'm going to write the minimum one right smack in the middle here. And that one's going to be at, let's see, 5 and 2. That's going to be at 7. So now go to 17 because it repeats every 10 seconds and put another minimum. Go to 27 and put another minimum. Go to 37, put another minimum. There you go. Now try to, it doesn't have to be perfect. Try to make the point of inflection hit the sinusoidal axis. It doesn't have to be perfect, but just try. So let's see. Yeah, that looks pretty good there. And that one didn't come out all right, but that's fine. That one looks pretty good. And there you go. You got yourself a sinusoidal axis. A function. Haha, LOL. All right. Hopefully everyone has that right there. Let's continue. So let's see what letter B says. Letter B says, assuming that D is the sinusoidal function of time, t, write a particular equation. Confirm the graph that the equation gives you the graph you sketched in part A. All right. So here are the letters they want you to use, guys. Assuming that D is a sinusoidal function of t, so they want you to use D and t. That's not a big deal. All right. So here we go. I'm going to find the amplitude first. Let's see. I'm going to write everything out here in the beginning. So here's the equation you're going to use. Let's go back to red because I like red. We're using a peak. So because we're using a peak, we're going to use cosine. So A cosine B x minus c close plus d. But instead, this letter here, we want to make that a t, and then that letter there, we're going to make that a little d there. All right. So here we go. The amplitude is 7, the distance between 6 and 13, or the displacement between 13 and 6. The sinusoidal shift, C, is 2 to the right. Let's see. The sinusoidal axis, D, is 6. The B, all right, so the B is going to be 2 pi divided by the period. The period is 10. So 2 pi divided by 10 converts to pi over 5. And I think we have everything we need. So here we go. Little d is equal to, let's see, 7 cosine, open parenthesis, pi over 5, open parenthesis again, t minus 2, close, plus 6. And that's it, guys. That's the equation. Cool, right? Cool. All right. Letter C. It says, how high above the water or below the water surface will point P be at the time t equals 17.5 seconds? At what time will it be going up, or at that time will it be going up or down? All right. So this is a pretty straightforward one, guys. I don't have the emulator in this TI. I don't have the emulator in this Surface Book. My apologies. So what you're going to do, you're going to click y equals on your calculator. And on y1, you're going to type in 7 cosine pi over 5, open parenthesis, x minus 2, close, plus 6. Now to get the little fraction feature, you got to push alpha y equals. Alpha y equals. And then just push enter and you'll get the little fraction feature. So let me do that right now. So let's do that right now, guys. I'm doing it myself too. Let's see. 7 cosine power 5, open parenthesis, x minus 2, close, plus 6. All right, before you push graph, you want to be able to look at the graph, guys. So here's my window. So click on a button called window. So click on window. And here's what you're going to make your x min. Window, make your x min. Make it like -1. X max, make it, well, they only want 17.5, but make it like 40 or 42. X scale, it doesn't matter, guys. Go by like 5 if you want. Y min, well, you only go to -1 again, so to make it like -3. Y max, make it 15. And then Y scale doesn't matter again. You can make it like by 1. All right, now push graph. -1, I haven't done my scale yet, so wait up, guys. X scale, -3, 15. All right, we're ready to rock and roll. Cool. I'm looking at a graph right now. I know you can't see it, but hopefully you're seeing it. Type in, so how do I figure out where you're at 17.5? Push the trace button. The trace button on the very top, you have a button that says trace. Push that button, and then once you push that button, insert 17.5. So I'm doing that myself too. 17.5, and then push enter. Here's what I get. In the bottom, it tells me that my x value is 17.5, and then my y value is negative 0.657396. So you're right. I'm going to do it in black here. You're right there. 17.5. So, and you can see, if you look at it very closely, it's going on the way up, because you read a graph left to right. So it's going on the way up here. So, let's see, how high above or below the water surface will point P be at the time 17.5? So point P, so let's write a statement really quick. Point P is negative 0.657396 feet below, or actually, well, if I'm going to write the word below, take out the negative there. Point P is 0.0657396 feet below the water, the surface of the water, below the surface of water, period. And let's see, it is going up. Point P is going up. Point P is going up. And that's it, guys. All right. So next, letter D. At what positive time t was point P first emerging from the water? So that means that. So I'm gonna look at here your graph, guys. So that means, where is point P first emerging from the water? So as you can see, this part that I'm circling, it's not emerging. That's when it's first going into the water. So when is it first emerging? This second one that I'm circling right here, guys. At that moment, I am first emerging from water. First emerging from water. So how do I find that out? I'm going to go to my calculator, and I'm going to push something, go to calculate, so second trace button, and click on something that says 0. I actually don't have a TI-84 with me, guys, so I have to do this off of memory here. Let's see, F5 on mine. Okay, so now that you push 0, it's probably going to say lower bound or upward bound. So all that means is to look, like to give it instructions of where to look. So I know this is hard without actually seeing the picture of the calculator. So tell it where to look. So when it says lower bound, go below and then push enter. And then when it says upper bound, go above and then push enter. It might say the word guess, it might not. So here we go. I found that it first emerges from the water at t equals 7.86119 seconds. If you got that value, you are pretty cool. And if you didn't get that value, well, no, I'm kidding. You're still cool. It's just, you didn't get it. If you're having issues, I guess I'll be back tomorrow. So if you're having issues, ask me tomorrow. But here we go, guys. Let's go to the next one. The next one's really cool. I really enjoyed this next question. Okay, so I guess, should I read it out loud? Yay? Yes? No? Yes? Okay. I'm kidding, guys. I can't really hear you guys, but I'm going to read it anyways. See, you being a super awesome engineer. Haha. Awesome engineer. Fiesta, Texas hires you to build a portion of a roller coaster track on the shape of a sinusoidal. So here's your track. You have been hired to calculate the length of the horizontal and vertical support beams. The high and low points of the track are separated by 50 meters horizontally, and they tell you that right here, and 30 meters vertically, and that's also told right there. The low point is 3 meters below the ground. So here's the low point, and that is 3 meters below the ground. Let y be the distance in meters. A point on the track is above the ground. Let x be the horizontal distance in meters. A point on the track is from the high point. Find a particular equation for y as a function of x. Oh, that's cool, guys. So it's pretty much just telling us to find an equation for this dude right here that I'm highlighting in red. And that shouldn't be hard to do. That looks pretty straightforward. So let's see. What do we do first? I guess we're going to be using cosine because we're using this peak right there. Let's find the period first. let's see. So I have from highest to lowest, it's 50 meters. And this is 50% from high to low. High to low. That's 50% of cycle. So that means that my period would have been 100 meters because I got to double it. So the B is 2 pi over 100, which reduces to pi over 50. So there's my B. Next, maybe I would do the amplitude next. So let's see, the amplitude, they told me that my vertical displacement is 30. So 30 divided by 2 will give me the amplitude, because remember the amplitude is from the halfway mark all the way to the highest point. So 30 divided by 2 is 15. Next, I'd probably do the sinusoidal axis. So let's see, the D, the highest point, they told me, if this is 30 and that's negative 3, so then this has to be 27, because, 30 minus 3. So 27 plus a negative 3 divided by 2, so that's 24 divided by 2, so I get 12. I think, do I have everything? Let's see, A, B, oh, the C. Well, the C is 0 because I haven't moved. So here's your equation, guys. Y equals 15 cosine, open parenthesis, pi over 50, x, close it, plus 12. And you're done. That's it. Cool or not cool? Cool. Okay. Haha. All right. Let's go down to the next one, guys. The vertical support beams are spaced 2 meters apart, starting at the high point and ending just before the track goes below the ground. Make a table of values of the length of the beams. Okay. So pretty much what they want to know here, let's see, what do they want? They want to know this. So I'm going to put them in red. I'm going to erase this here so you can see it. They want to know the heights of these vertical beams. So that first vertical beam at 0 is 27. There's no denying that. Then this one here is a little smaller than 27, and the next one's a little smaller than that, and the next one's a little smaller than that, all the way until you reach right here before you go underground. So they want to know the height of those vertical beams. Well, luckily, I have an equation that tells me that, guys. So I'm going to write right here, I'm going to go x, and I'm going to write y, and this is the vertical beam length. Vertical beam length. All right, at 0, it better be 27. So how are you going to find that out? I'm going to type in this equation into the calculator. So on y1, you type in 15 cosine pi over 50 x, close it, plus 12. So that's what I'm going to do right now, guys. So let's all do that really quick. I'm going to go to y1. Come on, buddy. All right, I'm going to type in 15 cosine pi over 50 x, close, plus 12. And then I'm going to go to this table. So table, at 0, I'm 27. Good. It's supposed to be that, guys, at 0. At 2, I get 26.882. And you're going to keep going until you are no longer, until, let's see, it says here, before the track goes below the ground. So you're going to keep going as long as you don't have negative values for vertical beam length. So 4, 26.529. And this is all in meters, by the way. Meters. 6 is 25.947. 947. 8. 25.145. All right, guys, take it away. I'm not going to show them all because I want you guys to write some of them. So make sure you write some of them, guys. Go all the way down. So I'm going to put a little asterisk here. You show them all, please. Try to. If you have to take up some of the other page, go for it. It looks like it's going to go all the way to 38. So I'm going to show 36. 2.4386 to 38, 1.0655. All right, guys, pause it a little bit so you can finish up. All right, here we go. I'm going to continue. Oh, sorry, that was an awkward pause there, guys. I was trying to clean my little laptop here. All right, letter C. The horizontal beams are spaced 2 meters apart. Start at ground level and ending just below the high point. Make a table of values of the horizontal beam length. Okay, so now what they want, I'm going to do it here in blue. They want these lengths. They want this. You see that in blue here? That's what they want. So that first beam, that horizontal, well, that first horizontal beam, it's going to be slightly larger than 38, but not too much larger. And then this one's going to be smaller than that number, and then that one's going to be smaller than that, and that one's going to be smaller. So there you go, all the way until you go to 26 here. At 26, there's a small beam. At 27, you don't have any beams because at 27, that's your peak. So that's what they want, starting at y value 0, 2, 4, 6, etc., etc. So what we're going to do, let's see, the horizontal beam must space 2 meters apart, start at ground level, and then just below the high point, make a table of values. All right, so what we're going to do, you're going to take your equation, and you're going to solve for x, guys. So we're going to do the inverse of it. So 15 cosine pi over 50 x, close it, plus 12. Okay, so the first thing you got to do is move the 12 to the left. And I'm going to rewrite this, guys. I like to have what I'm solving for on the left-hand side. So I'm going to rewrite this as 15 cosine pi over 50 x, close it, equals y minus 12. Are we cool right now, guys? All right, next, what I'm going to do is I'm going to divide by 15 because I got to get rid of that 15. Divide by 15, divide by 15. So now I have cosine pi over 50 x equals 1 minus 12 over 15. All right, now I need to get rid of the cosine, so I'm going to do the inverse of it. So pi over 50 x equals, I'm not going to write plus minus because you're not interested in the negative values, guys. So I'm going to write arc cosine of y minus 12 over 15. I'm not going to put plus 2 pi n because I don't have a whole period. This roller coaster does not repeat the sinusoid over and over again. So there's no reason to be writing that. So to get rid of the power of 50, multiply by the reciprocal. So you have x equals, let's see, x equals 50 over pi, sorry, arc cosine of y minus 12 over 15. And I know what you're thinking. You're like, man, Chavez, there's no space for me to write my table. Like, yeah, there is. So here's your table. You're going to put the y value first and the x value right here. I'm going to put y value in quotes because we're going to do something about it right here. And then x, where this is a horizontal beam length. Horizontal beam length. So here's what you're going to do, guys. Insert this into your calculator, and here's how you're going to insert it. Go to y2, leave y1 alone, and type it as 50 over pi, arc cosine of x minus 12 over 15. So do that in y2, guys. Okay, I'm going to do that too as well. Okay. 50 over pi, parenthesis, our cosine. Don't forget to use the fraction feature, guys, or else, remember, the calculator is just a stupid piece of machine. So use the alpha y equals feature so you can have perfect answers. All right, so here we go. I'm going to look at a table. And after you go past 27, it better say undefined because there's nothing up there, guys. So at 0, when you do understand that at 0, you're finding when y is 0. So you're finding this guy down here at the very bottom. And at 2, when y is 2, quote unquote, you're finding that. When y is 4, quote unquote, you're finding that. When y is 6, that's what you're finding. So I hope you're not robots here. So here we go. 0, it says 27. Well, no, 0, it says 39.758. Sorry about that. 758 meters. And it makes sense because I think that's when you start going underground. The other one, I think when we did our x values here, look, we went all the way to 38 because at 40 it was already in the negatives. So yeah, perfect. Perfect. All right, at 2, it is 36.614. At 4, it is 33.953. Keep going, guys. All the way down to 5, 4, 9. Keep going. All the way to 26. At 28, you're going to have an error. At 28, you're going to have an error. So go all the way to 26. 5.8443. And then pause this if you need more time to write all those values down. But I would write them down somewhere. I would not just leave it the way I have it here because, you want to be good engineers in the future. Or maybe, you're going to have them in an Excel file or something like that. All right. So letter D. It's kind of hard to show it. Ask some of the statistics people. They're pretty good at this. It says you must know how much support beam material to order, because you're the engineer. You're going to be ordering all this in the most time-efficient way. Notice it says time-efficient. Find the total length of the vertical beams and the total length of the horizontal beams. All right. I already have my vertical beams. Inserted in Y1. And I have my horizontal beams inserted into Y2. So to make life easy for you, and I don't have a TI-84 with me here, but to make life easy for you, all you're going to be doing is summing them up. So like Chavez, what are you talking about? Look at all this, guys. So you can either choose to sum them up one at a time. 27 plus 26.82 plus 26.529 plus 25.947 plus 25.145 and keep going all the way until you get 38. But that's not going to be time efficient. See, it says time efficient. So here's what you do. This sigma here stands for sum. And I'm going to sum Y1. Now notice, we want to sum it goes 0, and then it goes 2, and then it goes 4, and then it goes 6, and then it goes 8. So we want to skip the 1, we want to skip the 3, we want to skip the 5, we want to skip the 7. So to skip those, you go y1 of 2x, and that will skip them. And you start at x equals 0. See, so if x equals 0, you get y1 of 0. If x equals 1, you get y1 of 2. If x equals 2, you get y1 of 4. If x equals 3, you get y1 of 6. So it skips all those intermediate ones. And since we want to go all the way to 38, 38 divided by 2, what is that? 19. So you're going to go all the way from 0 to 19. And to find this on your calculator, it's under math. And then look for something that says sum. And that's what you're typing. That's what you're just pushing that, and you're just pushing those numbers in there like that. So what I got when I did that, let me do that. I don't have a TI-84, guys, so I can't give you the exact. I have a TI-89 with me here. So I should have brought a TI-84 with me. So let me do that really quick. Let's see. 0 to 19, y1 to x. I get... Come on, buddy. Okay. I get 323.637 meters. And for this one, let's see, sum from x equals 0, y2 of 2x all the way to, let's see, 26. So the 26 divided by 2 is 13. And I get, so let me do that one now. .844 meters. All right. If you don't know how to do that, relax. I will be back tomorrow. D is not necessarily super important, but it'd be good if you know it, especially for you statistics people. I think they're pretty good at this probably. But all right, guys, I think we are good, and I hope that you enjoyed this video. Thumbs up if you liked it. Subscribe if you loved it. And I'll see you guys when I see you guys. All right. Bye.